So question 8 is a very typical type of question. You need to identify the strongest type of intermolecular forces exhibited in the liquid state. Now, even if the question doesn't say so, whenever it asks for the type of intermolecular forces, it normally implies the strongest, unless you have a question that say identify all types of intermolecular forces, which is not the case in this question. This question just asks for the strongest. So when we talk about intermolecular forces, there are a few things that you need to really consider. And the first question to ask, and I do believe we handed out a flowchart last term, the first question is it symmetrical, polar or nonpolar? Actually, you talk about is there a difference in electronegativity, and then we talk about is it polar or nonpolar, and then we look at whether or not you have hydrogen bonded to nitrogen, oxygen, or fluorine, which will give you hydrogen bonds. So if we look at the first case, there is definitely a difference in electronegativity between these two atoms. Chlorine is more electronegative than hydrogen. So if I just draw the structure out, it's a single covalent bond between hydrogen and chlorine. You don't really need to consider polarity when you see something like that. It's definitely polar because even though the shape is linear, the shape doesn't actually imply polarity in this case. Definitely this is a negative dipole and that's the positive dipole. There's only two atoms anyway. And the strongest intermolecular force should be dipole-dipole. Okay. Second case, oxygen. Now, if you see anything like this, there is no difference in electronegativity. The two atoms are identical in type. So the only type of intermolecular force possible is dispersion force. This is probably the easiest case. And you can do the same for this question right here. You have the same type of element, no difference in electronegativity, which means you're going to have a non-polar molecule. So the strongest type of intermolecular force is present will be dispersion force. All right, we're going to go to C. Now C, you get better at this the more you do it. But if you think about what nitrogen ammonia looks like, first of all, you definitely have a difference in electronegativity because nitrogen is more electronegative than hydrogen. Now the next question we need to consider is whether or not the molecule is polar. And nitrogen will form three bonds and it still had a lone pair up here. So this shape, if you consider the electron geometry, will be tetrahedral, but the shape of the molecule is trigonal pyramidal, so it is non-polar. Sorry, it is polar because the shape is asymmetrical. Now, if it is polar, it could either form dipole-dipole, which is the case of HCl, but this is nitrogen covalently linked to hydrogen. So this is one of the three cases when you actually have hydrogen bond as the strongest intermolecular forces. Okay, that does not look like a H, so I'm going to change that because I tend to ridicule people for terrible handwriting, so I guess I should do the same for me. There you go. Okay. D. Now, so we have something like CHCl3. So there is definitely a difference in electronegativity between the carbon and the chlorine, as well as the carbon and the hydrogen. And even though the shape is tetrahedral, this is still a polar molecules because the negative dipoles, which is the three chlorine atoms, are not evenly distributed. This is more negative than carbon, but carbon is more negative than hydrogen. So this is polar, which means that the intermolecular force, the strongest one, will be dipole-dipole. Okay, OCl2. So once again, it is a very good idea to draw the structure out or some sort of the structure. You do want to be able to tell what the shape is. There is a difference in electronegativity between chlorine and oxygen. So you definitely have polar bonds here. And if you think about what the shape is, this is a terrible drawing, but the shape of this, because oxygen has two lone pairs of electrons, the electron geometry will be tetrahedral and the molecular geometry is actually V-shaped. It's very similar to H2O. So you have the two lone pair of electrons, and then you have one chlorine here, and then you have one chlorine here, something like that. So it's definitely polar, which means that the strongest intermolecular force present will be dipole. Okay. SiH4, once again, you have a different in electronegativity. You will have a different in electronegativity every time you have two different types of elements. But silicon, I think, will look something like this. Now, I'm going to confess I don't remember where silicon is, so I'm going to look it up. I have an inkling, but let's just see whether my inkling is right. Yes, so silicon is below carbon on the electrochemical. It's below carbon on the periodic table, so it also has four valence electrons available for bonding, and it's going to form four bonds, which means that the shape of SiH4 will be tetrahedral, which will mean that the molecule will be nonpolar, and the strongest intermolecular force will be dispersion. Okay, HF, easy, hydrogen bond. Definitely polar. Fluorine is the most electronegative element. You only have two atoms, so there's really nothing to cancel out the polarity. And fluorine is one of the three unique cases when hydrogen bonds can be formed. So there you go, question 8.